Hi everyone, Mr. Boltri here bringing you video 5.5. We're going to talk about rotational dynamics. So in this video, we're going to focus just on Newton's second law of rotation, or as applied to rotational forces and motion. So first, we have to remember, what is Newton's second law of linear motion? And hopefully you know just off the top of your head that force equals mass times acceleration. Except we're missing something. Don't forget that force and acceleration are both vectors, and then we're good. Actually, I tricked you again. We actually have to include the net force equals the mass times the acceleration. In case there's more than one force, we have to look at the net force. So this is really important to know. The net force equals the mass times the acceleration. So now we can think about what is the analog in rotational motion. Well, the analog for force, the rotational force, we've called torque. Rotational mass, we've called the moment of inertia, and then there's just angular acceleration. So just easy translation over here. We can say the net torque equals the moment of inertia, the angular mass, times the angular acceleration, where these are both vectors, and we look at the net torque, we sum up all of the torques to find the angular acceleration. So that is Newton's second law of rotational motion. And this is Mr. Boltri wrapping up video 5.5, because honestly, this is the most important fact in this video. And this idea, this concept, just like the Newton's second law, for net force equals mass times acceleration, net torque equals moment of inertia times angular acceleration, is going to unlock and allow us to solve a whole bunch of problems where we have to draw a force diagram and then look at the torques where we calculate those by using the right-hand rule. The direction of this is really important, using the right-hand rule for the moment arm, and then the direction of the force to find the direction of the torque. And then the direction of the angular acceleration is going to be in the same direction. So this formula, we are going to use so much to solve so many problems. So I don't need to talk too much more about it. I'm just going to wrap up the video and then looking forward to doing practice problems with you in our next class. But for now, go Bears.